Section 4. Core Azure Services. In this section, we will cover the following topics: the evolution of cloud compute services, Azure Virtual Machines, Azure Container Services, Azure Functions, Azure Storage Services, Azure VNets and Subnets, Azure Database Services, Azure Marketplace, Azure CDN. Video 4.1. The evolution of cloud compute services. In this video, we will cover the following topics: virtual machines, containerization, function as a service. A few decades earlier, physical servers were used for running applications. They were also called dedicated servers because a single customer wholly uses the servers. However, you need to guess your server capacity depending on your workload. Optimizing the server load is a problem because if we assume that your application needs 4 servers during high traffic and at other times it needs only 2 servers, then you will end up paying for 2 underutilized servers because they are only used when there is a heavy load to the application. The servers which are always running will also be underutilized because the applications which were deployed in the servers would not consume the whole space. There would also be a lot of space that is left unused. All this adds up to a lot of capital expenditure. You need to buy yet another new server if the application capacity or the load increases, and this process is very slow and expensive. Besides, you can only install a single operating system on your servers. However, despite these pain points, one main advantage of using dedicated servers is that your data will be secure and private to your server. But as technology evolved, cloud computing came into the picture and it introduced the concept of virtual machines or VMs. What are virtual machines? They are also servers or computers which contain CPU, memory, and storage, which can be used virtually over the internet. You don't need to buy a physical server. You can rent the server for your usage. But what happens when you spin up a virtual machine? A piece of software will be installed in your rented computer over the layers of your rented system's hardware. This software which is installed is the hypervisor. Earlier, a single OS could be installed on a single computer. But with virtualization, multiple instances of operating systems can be installed on the hypervisor. These instances are known as virtual machines. With virtual machines, a single physical server can be shared by multiple customers. With virtual machines, you don't need to buy the complete physical server. You just rent the server over the internet, so your capital expenditure is eliminated and is converted to operating expenses. Even with a virtual machine, there would be wastage of the space because you need to install a particular size of a virtual machine which you may not use completely. There will also be a conflict in resource sharing if multiple apps are running in a single VM. This could be eliminated if different apps are deployed in different VMs. If the concept of VM is confusing, let me give you an analogy. Consider that dedicated servers are like parents dropping their children to school using their vehicles. With this, parents need to spend on gas, petrol, or on the maintenance of the car or vehicle. Then school started a school bus service, and with this, all the children can go in a single vehicle. The school maintains the gas, petrol, etc., and you only need to pay for using the bus, which is way lesser than what you spend on your vehicle. The concept of virtualization became popular, but then containers are making headlines as they are much more efficient than virtual machines. What are the containers? Containers are similar to virtual machines, but they use fewer resources than virtual machines. In containers, there is a container engine instead of a hypervisor. Virtual machines are not present. Instead, we will have containers with applications and their libraries, tools, etc. The containers use the host OS only. If there is a requirement of some other operating system other than the host, a virtual machine can be created on which the container engine and the containers can be run. Multiple applications can be run side by side within a single machine without having any resource sharing conflicts. There is no wastage of space and memory, and they will be used as per the application's requirement. Consider this example to get more clarity. Think of individual houses and apartments. Individual houses have separate land, power supply, water supply, etc. They are comparable to VMs. At the same time, an apartment building contains many flats. All the flats are built on the same land, use the same power and water supply. This is analogous to the container. After containers, next comes function as a service. In this, a single application is divided into many functions. Then, instead of running the whole application, you can only run the needed function. It is a part of serverless compute because you do not need to worry about provisioning or managing the servers. You can upload the code for your function and only pay for the amount of time you are running the function. Functions as a service is very cost effective. Deploying is also very easy. Serverless can be compared to a taxi car where you do not need to worry about investment, maintenance, and fuel. You can use them when you need them and pay for what you use. In summary, in this video, we have covered the following topics: virtual machines, containerization, function as a service. In the next video, we will take a look at Azure Virtual Machines.